friends, it's Shannon Math Chick Myers coming to you live from San Diego, and today we'll be talking about a few misleading graphs. So let's get going. What do you think about this one here? I mean, gosh, look at that massive increase in house prices this year from 98 to 99. This is, by the way, in pounds. So what do you think about it? Notice anything? Yeah, maybe that scale's a little bit off. If you take a look at one that starts at 0, right, and then has the same value per tick mark on that vertical axis of 10,000 pounds, this one has a value of 80,000 pounds in this tick mark, and then it goes from 1 to 1,000 increases. So it makes the difference look huge right here, when in reality it's pretty flat, right? So that is one example. Here's another one. Again, not starting at 0 on your vertical axis. And look at the amount per tick mark here. It's 2 1,000ths, but 2 1,000ths of a percent, which is very, very small. Here's a little more realistic. It goes by 0.5%, right? And what you'll notice is that it's really pretty flat. The interest rates are fairly flat from 2008 to 2012, right? So another way is pictographs. I love these. This one has a scale that starts at 0, right? And it's the same with each tick mark, but it doesn't say what unit it's being measured in. Is it some kind of volume measure? Is it pounds? Is it per family on average? We don't know. So what we do know is that in 1960 there's this little teeny trash can that it looks like maybe it had 100 units of trash. In 1980, gosh, we'd expect to see some huge increase. But if you think about it, it's not that much more, because it's maybe at what, 170, 80, probably 180, depending on where you're supposed to go for the mark. So that's only an 80 unit increase from 1960 to 1980, but it looks a lot different. And then if you go to 2000, holy moly, look at that. Again, it's like about maybe 255. You look at 255 compared to 180, it's roughly a similar increase, maybe even a little bit less, but it looks just gigantic. So that's one. At least they had some sort of scale, even though we don't know what the units were. Home sales. Look at this one. No scale at all. Just a little house in 2000, and the same house but giant in 2001. So I don't know what we're supposed to think of that. I mean, if you think about how many of these little houses could fit in the big house, you're probably talking 3.5 maybe, or 4. Does that mean it was 3.5 times as much? We just don't know. And people shouldn't have to be asking themselves questions about this. So here's kind of a cool graphic. This kind of improper scaling, right, where this is this gigantic person, when it really should be the same size. If you're going to use a pictograph, you use the same size. Because look, you can fit about 9 little people into the big giant person. All right, now let's look at these. I looked up the worst graphs in 2017, and here we go. So take a look at this one. It's about when Florida enacted its Stand Your Ground law, and they're measuring the number of murders committed using firearms. So, first of all, they're starting 0 right here and counting in positive numbers going down, which in and of itself is very confusing. And so here, before the law was enacted, it makes it look like the amount of deaths were very low, right? When in fact they were at their highest point in the early 90s. And then it decreases, it keeps decreasing, but it looks like it's increasing, right? And then it starts increasing again, right here. The amount of deaths start increasing. Then another decrease, right? And then there's an increase again after the Stand Your Ground law. But notice that, I mean, you really have to think about what this graph is saying. The reverse scale is very confusing. And why is there all the shading here? It looks weird. So anyway, that was a classic. And check this one out from Fox News, Obamacare enrollment. So instead of having a vertical scale right here, they've got this little bar that has a value of 6 million enrolled versus the 7,066,000, which is the goal. Well, if you think about what portion of 7,066,000 6 million is, isn't it about 6/7? So shouldn't it be, I don't know, the bar should probably be somewhere up here, shouldn't it? So this is another classic. And just to be fair, I brought something from CNN, and it says here that each line is 2/100ths of a second. But what does this mean? I mean, the length of these lines, it seems like the top one should be the, highest number of seconds. Look here, you've got more seconds, but you have a shorter line, and etc. So anyway, that's it for this little lesson, and I hope you have a wonderful day or evening or afternoon, whatever time you're watching this. Bye.